According to the National Electrical Code, specifically Article 680, Part 6, Section 680.26, metal poles must be electrically bonded to the grounding system. The bonding conductor must be a solid copper conductor, and it must not be smaller than number 8 AWG. The term continuous loop in NEC 680.26 subsection B is not explicitly defined. However, it is generally interpreted as a single conductor that runs around the entire perimeter of the pool and connects to all the metal components that are in contact with the pool water. The inspector's reasoning that the continuous loop should go completely around the pool is rooted in the need to ensure that all metal components are interconnected, providing a low resistance path to ground. This helps to prevent creating a potential difference between different sections of the pool, which could pose a shock hazard. While it is possible to bond metal pools using individual connections to each metal panel, the common practice is to use a continuous loop. This approach is more efficient and provides a more secure connection. To resolve the issue and ensure the pool passes inspection, it is recommended to modify the bonding system as follows. Firstly, run the continuous number 8 solid copper loop completely around the perimeter of the pool. Secondly, attach the loop to each metal brace using approved direct burial fittings. Thirdly, ensure that all metal walls, braces, and hollow components are properly bolted together. By completing the loop around the entire perimeter of the pool, you ensure that all metal components are interconnected and provide a low resistance path to ground. This meets the NEC requirements and ensures the safety of the pool occupants. To delve deeper into the specifics of pool bonding and grounding, let's break down the key elements and considerations. The purpose of bonding and grounding in a swimming pool environment is to minimize the risk of electrical shock to people in or around the pool. This is achieved by creating an equipotential plane, meaning that all metallic parts within reach are at the same electrical potential. This way, if a fault occurs, the voltage difference between these parts is negligible, preventing a dangerous current from flowing through a person's body. The number 8 AWG solid copper conductor is the minimum size required by the NEC for the bonding loop. It is crucial to use solid copper because it is more resistant to corrosion than stranded copper, especially when buried in the ground or exposed to pool chemicals. The continuous loop configuration is preferred because it provides multiple paths for fault current to flow back to the source. This redundancy ensures that even if one connection fails, the bonding system will still be effective. The loop should be installed around the entire perimeter of the pool, connecting to all metal parts, including the pool walls, metal braces, pump motor housing, metal conduit, and any other metallic components within 5 feet of the pool's edge. Each connection point should be made with approved direct burial fittings. These fittings are designed to withstand the corrosive environment around a swimming pool and maintain a reliable electrical connection. Avoid using wire nuts or other unapproved connectors, as they can corrode and fail over time. When drilling into the metal braces or pool walls, be sure to use a drill bit that is slightly larger than the diameter of the bonding connector. This will ensure a tight fit and prevent the connector from loosening over time. After making the connection, apply corrosion inhibitor to the exposed metal to protect it from the element. In addition to the bonding loop, the pool pump motor must also be properly grounded. This is typically achieved by connecting a grounding conductor from the motor housing to the equipment grounding conductor in the electrical panel. The size of the grounding conductor should be determined based on the size of the motor's overcurrent protection device, in accordance with NEC Table 250.122. All metal conduit and junction boxes associated with the pool electrical system must also be bonded and grounded. This includes the conduit that carries power to the pump motor, as well as any junction boxes used to splice or terminate wiring. When installing electrical equipment around a swimming pool, it is important to maintain proper clearances from the water's edge. The NEC specifies minimum distances for receptacles, switches, and lighting fixtures to prevent them from being accidentally submerged or splashed with water. Receptacles must be at least 10 feet from the inside wall of the pool, unless they are GFCI protected and located at least 6 feet away. Switches and lighting fixtures must also be located at least 5 feet from the inside wall of the pool, or they must be GFCI protected. Underwater lighting fixtures must be specifically listed for swimming pool use and must be installed in accordance with the manufacturer's instructions. These fixtures typically operate at low voltage, such as 12 volts, to reduce the risk of electrical shock. When backfilling around the pool, be sure to use clean fill material that is free of rocks, debris, and sharp objects. This will help to protect the bonding conductor and prevent it from being damaged. After the pool is filled with water, it is a good idea to test the bonding system to ensure that it is working properly. This can be done using a multimeter to measure the voltage difference between various metal parts around the pool. The voltage difference should be negligible, typically less than 0.5 volts. If you find a significant voltage difference, it indicates a problem with the bonding system that needs to be corrected. Remember that electrical work around swimming pools can be dangerous, so it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. An experienced electrician will be familiar with the NEC requirements for pool bonding and grounding and can ensure that the installation is done safely and correctly. In summary, proper bonding and grounding are essential for the safety of swimming pool occupants. By following the NEC requirements and best practices, you can minimize the risk of electrical shock and ensure that the pool is a safe and enjoyable place to swim. Remember to always consult with a qualified electrician if you have any questions or concerns about pool electrical safety. The continuous loop, made of number 8 solid copper wire, serves as the backbone of the pool's bonding system. Its primary function is to connect all metallic components of the pool structure, creating an equipotential plane. This plane ensures that all conductive surfaces within reach are at approximately the same electrical potential, minimizing the risk of shock. The NEC mandates this continuous loop to mitigate the potential for voltage differences between different parts of the pool, which could lead to dangerous electrical currents flowing through a person in the water. The loop should encircle the entire perimeter of the pool, connecting to metal walls, supports, ladders, and other metallic fixtures. The connections must be robust and corrosion resistant, utilizing approved direct burial fittings designed to withstand the harsh conditions present in a pool environment. These fittings typically involve clamping or bolting the copper wire to the metal components, ensuring a secure and low resistance connection. The inspector's insistence on completing the loop is not merely a matter of strict code compliance, but a crucial safety measure. Incomplete loops can create isolated sections of metal that are not adequately bonded, leading to potential voltage gradients and increased shock hazards. While individual connections to each metal panel might seem sufficient, they lack the redundancy and overall effectiveness of a continuous loop. The continuous loop provides multiple paths for fault current to flow back to the source, enhancing the reliability of the bonding system. It also helps to equalize the electrical potential across the entire pool structure, minimizing the risk of localized voltage differences. The recommendation to modify the bonding system by completing the loop and ensuring proper connections is based on sound engineering principles and the intent of the NEC. By following this advice, you not only satisfy the inspector but also create a safer swimming environment for everyone. This involves carefully inspecting all connections to ensure they are tight, corrosion-free, and properly rated for direct burial. It also entails verifying that all metal components are securely bonded to the loop, leaving no isolated sections. Furthermore, it is essential to ensure that the pool pump and other electrical equipment are properly grounded. Grounding provides a direct path for fault current to flow back to the source, tripping the circuit breaker and energizing the equipment. The grounding conductor should be sized according to the NEC and connected to the equipment grounding terminal in the electrical panel. In addition to the bonding and grounding system, ground fault circuit interrupters, or GFCIs, provide an additional layer of protection against electrical shock. GFCIs are designed to detect even small leakage currents and quickly de-energize the circuit, preventing a potentially fatal shock. The NEC requires GFCIs to be installed in all receptacles within a certain distance of the pool, as well as for underwater lighting and other pool equipment. When working with electrical systems around a pool, it is crucial to follow all safety precautions. Always disconnect power before working on any electrical components, and use appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable performing electrical work, it is best to hire a qualified electrician who is familiar with pool electrical systems. Remember that electrical safety is paramount, and even a small mistake can have serious consequences. By understanding the principles of bonding and grounding, following the NEC requirements, and taking appropriate safety precautions, you can ensure that your swimming pool is a safe and enjoyable place for everyone. The continuous loop not only connects to the metal walls but also to any other metal components that are part of the pool structure or within a certain proximity to the pool. This includes metal ladders, handrails, diving board supports, and even metal fences or gates. The goal is to create a comprehensive equipotential plane that encompasses all conductive surfaces within reach of swimmers. The connections to these various metal components must be made with the same care and attention to detail as the connections to the pool walls. Approved direct burial fittings should be used to ensure a secure and corrosion-resistant connection. The size of the bonding conductor should be sufficient to carry the expected fault current. While number 8 AWG is the minimum size allowed by the NEC, a larger conductor may be required for larger pools or pools with extensive metal components. The bonding conductor should be run in a direct and unobstructed path, avoiding sharp bends or kinks that could increase its impedance. The conductor should also be protected from physical damage, such as being run over by vehicles or being exposed to sharp objects. In addition to the continuous loop, the NEC also requires that the pool water be bonded. This is typically achieved by installing a bonding jumper between the pool water and the bonding grid. The bonding jumper should be made of solid copper wire and should be sized according to the NEC. The purpose of bonding the pool water is to equalize the electrical potential between the water and the surrounding metal components. This helps to prevent voltage gradients from forming in the water, which could lead to electrical shock. The bonding jumper should be installed in a location where it is not likely to be damaged or corroded. It should also be protected from physical contact with swimmers. The NEC also requires that all electrical equipment associated with the pool be properly grounded. This includes the pool pump, filter, heater, and any underwater lighting fixtures. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the equipment. The grounding conductor should be sized according to the NEC and should be connected to the equipment grounding terminal in the electrical panel. The grounding conductor should be run in a separate conduit from the power conductors. It should also be protected from physical damage. In addition to the bonding and grounding requirements, the NEC also specifies requirements for the location of electrical equipment around the pool. Receptacles must be located at least 10 feet from the inside wall of the pool, unless they are GFCI protected and located at least 6 feet away. Switches and lighting fixtures must be located at least 5 feet from the inside wall of the pool, or they must be GFCI protected. Underwater lighting fixtures must be specifically listed for swimming pool use and must be installed in accordance with the manufacturer's instructions. These fixtures typically operate at low voltage, such as 12 volts, to reduce the risk of electrical shock. The NEC also requires that all electrical circuits serving the pool be protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect even small leakage currents and quickly de-energize the circuit, preventing a potentially fatal shock. GFCIs should be installed in all receptacles, switches, and lighting fixtures within a certain distance of the pool. They should also be installed on the circuits serving the pool pump, filter, heater, and underwater lighting fixtures. When installing electrical equipment around a pool, it is important to follow all safety precautions. Always disconnect power before working on any electrical components, and use appropriate personal protective equipment such as rubber gloves and safety glasses. If you are not comfortable performing electrical work, it is best to hire a qualified electrician who is familiar with pool electrical systems. Remember that electrical safety is paramount, and even a small mistake can have serious consequences. By understanding the principles of bonding and grounding, following the NEC requirements, and taking appropriate safety precautions, you can ensure that your swimming pool is a safe and enjoyable place for everyone.